Makes sense evil here, but still, like, it's hard to know though.
All right, everybody shut up. Okay. All right, let's get going. So today, everybody online can hear me, see the screen, all that jazz?
Yep, all good.
All right, so we are going to take our next step here and start thinking about data structures in terms of, well, data structures and algorithms in terms of what we're going to do with this card game. So now it's, the idea is that there might be a bunch of cards out there, right? 1,000 cards. And last time we wrote some code that allows you to go and create instances of a card with just a couple of pieces of information, right? All right, so how many of you want the next homework assignment to be go and create 1,000 instances of cards by hand, putting in the name of the card, the mana cost, the attack, the defense? We don't want to do that by hand, right? That data is probably out there somewhere. All right, so now the question is how do we get data into our programs? All right, now some more modern languages have some better tools for doing this. Better is a vague word. More convenient tools for doing this, but we do actually have an interesting opportunity with C++ to leverage, especially on Linux, to leverage some of the Linux system calls to do this. So as an example here, I think well, let's just go over to the Linux side. I already wrote some of this. We don't spend tons and tons of time. All right, so we have this thing. First of all, let's just go back over here. So we can use a local file that has data in it. We can use a local or cloud database in different flavors. So when you take the 430 class with Dr. Wall, you'll talk about relational databases versus NoSQL databases, whatever. But here we're thinking about we have data stored somewhere and it's given to us somehow. Okay. Now, kind of related to this, but I'm going to put it on its own line, is this thing called an API. All right. So an API is an application programming interface. Specifically, we have these things called RESTful APIs, which use the HTTP protocol to communicate. Not that important for us right this second, but we have this thing called HTTP. We've seen it a zillion times. Every single time you go to a web page, it's HTTP // blah, blah, blah. Your web browsers speak the HTTP language. All right, pretty simple language, has 4 commands: get, post, put, and delete. How long has HTTP been around? Longer than all of you, right? Okay, do you think they probably have the bugs worked out of communicating between those 4 little things? So this, we can consider this thing as being a relatively stable medium, right? Especially since it's a computer language, it would be unambiguous, as opposed to like a language like English where we have nuance. All right, so what's interesting is APIs, specifically RESTful APIs, are a much newer occurrence in technology where we're using our programs to talk to some third-party source that has data available to us in some way. And the current cool kid way of doing that is through this idea of a RESTful API, which uses some old school language, HTTP, for talking to it. Unimportant for us from the details of that, but from a computer programmer problem solving perspective, the idea is that data that we want might be available out there somewhere, and with an internet connection, we might want to connect our programs to that data. Make sense? So initially here, what we're going to do is we're going to kind of operate off of this local file idea. We're going to say, what if a file was available remotely that had stuff in it we wanted? And the example we're going to look at here is, I just did a couple of searches. Blizzard, actually, the makers of Hearthstone, have their own RESTful API that allow you to pull in information about an individual card and stuff like that. And we might go and use that at some point if we want to get individual images or something. But for us right now, we're not interested in details about a card. We want the collection of cards that are available out there. And because we're focused on data structures in here, I wanted to give us a collection of data that is structured that we're going to have to write a set of classes to break it down. All right. So what I did is I found out there's this api.hearthstonejson.com. Here, I can give you I'll post it into Slack. That's the URL I'm on here. And also, let me, oh, sorry. I just went ahead and pushed my current, well, I'm in the middle of pushing it apparently. All right, push the current version of my code, which the example I'm going to go through today, up to GitHub, if you want to follow along or whatever. All right, but from our perspective, we have this wall of text that lives out there on the internet under this URL. And it's formatted in JSON format. All right. So I know we've talked about this before, but let's just throw a slide in here. So what is JSON? JSON is JavaScript object notation. So this is how JavaScript represents its objects and provides object-oriented programming. This also looks very similar to dictionaries mixed with lists in Python. All right, so we have a couple of different things that exist here. So we have this idea of a JSON object. Now, a JSON object comes in two forms. It's either a JSON array, like a list, and we'll say of JSON objects. We also have the idea of a collection of name value pairs. Values can be the supported types like ints and strings and stuff like that, or JSON objects / JSON arrays. So this describes what a JSON document might have in it. What we'll end up writing in here may not necessarily be full JSON parser support, but it should be pretty close. It'll at least give us practice writing the data structures for dealing with this. All right, so if I go ahead and I just go back over here to this code, and let me make this a little bit bigger. All right, so some of these things, if we start looking at it, should kind of look familiar. See this little opening square bracket thing that kind of looks like a list, right? So that's an array. This is an array of JSON objects that we're dealing with here. A JSON object always starts with an opening curly brace. So here's a JSON object. A JSON object, kind of like a dictionary from Python, where we also had curly braces, right? So notice this guy's a bunch of name value pairs. We have attack is equal to 0. We have card class is equal to neutral. We have cost is equal to whatever. Let's get down a little bit farther in here. So this is the end of that object. So this guy right here is a JSON object representing a card. Here is the next JSON object representing a card. Now notice this card's a little bit more complex. And actually one of the variables in here, this thing called play requirements, actually has another JSON object associated with it. The type of value is JSON object. Okay? But this is structured data that happens to follow the JSON format. So goal number one for us is we want to get this data into our program. Goal number two, process the data. Goal number three, put it into our card objects. Okay? So if we go back in here, initial goals, and let's see, did I get the URL? Get the data available above into our C++ program. Then parse the data into objects. Then build cards out of that parse data. All right. But before we can do any of that, we need to get this external data into our program. All right. Now, if we were doing this in like Java or Python, there are built-in, so how do we read from a URL, which is Universal Resource Locator, which is effectively saying, how do we read from a website? URLs are actually, they can be a little bit more complex than that. That doesn't have to be a website, but for all intents and purposes, when we say URL, we pretty much mean a website. Okay, so how do we read from a URL? Well, in Java / Python / C#, we have built-in objects that allow us to read from a URL. Why do you think this is? Why do you think they're part of the core language? In Java, it's java.net is where those things live for network stuff. In Python, it's, what is the Python library? Well, whatever it is, something similar, a network library in Python. Why do you think those exist in Python, but C++, we have to get creative? I'm going to say, that isn't to say that someone hasn't written libraries for this, but it isn't part of the C++ standard. Why is that? Why is it that C++ doesn't come with those tools, but Python and Java do? Go ahead. Okay, so internet wasn't around when C++ was made. Wasn't a thing. so the programming language didn't have that stuff in it. Now, the programming language also didn't have a more evolved version of the string class, which we're going to use in here for convenience. So those things had been added, and it's fair to say that there are tools out there that would allow us to do what we're going to do today, maybe in an easier way, but the exercise we're going to go through today is actually something unique to using C or C++ on a Unix or Linux platform. You know, we've already seen these command line tools that allow us to do some cool stuff on Linux or Unix. And you can do this on Windows as well with C++, but it makes a lot more sense on Linux or Unix because Linux and Unix have like a bunch of command line tools that allow us to accomplish things. There's already programs that exist inside of Unix for doing this. All right, so as an example, if I come out here to the terminal, now most of you are going to have to issue a couple of commands here. First of all, there's a tool called curl. So this is a client for URLs. So if you're on your computer and you type in curl and press enter, you're probably going to get command not found. If you're on Linux, is that a true statement? Okay, so if you're doing this, the first thing I want you to do, we're going to go ahead and just install a couple of things to make them available. So we're going to say sudo apt-get update. I always like to run an update first, just to make sure all the local stuff are, all the repository stuff is up to date. Only takes a couple of seconds. And then we're going to do a sudo apt-get install curl, like that. This is a client for URLs. And it's not going to install anything on mine because it's already the newest version. For you, you're going to get some version of curl installed. And once that's done, if you type in curl and press enter, you should get something else that appears there. All right, we good now? We got a living curl program. First of all, we see how easy that was to get a piece of software that wasn't already available to us installed. We didn't have to go hit a website and download and run a setup and all this other stuff. So even though it feels like it's more, you know, I don't know, it's more old schooly or inconvenient doing it from the command line, hopefully you're starting to feel that the command line is actually a pretty powerful place to be. And the web is kind of, that just makes it easier for people to navigate it, not necessarily faster to do things. All right, so now if you just type in, do curl, and the URL there is this guy, but you could type in http://www.google.com if you want, you know, just some website. And when you press enter, it's going to read from that website and give us back this, this data. And it'll just dump it to the screen. So far, so good. This is just proof that curl is working for us. Now, an interesting thing here is, let's say that I want to preserve this data just in case I run into a situation where this API goes offline or the internet's down and I still want to work on my code, something like that. So I can go ahead and when I run curl, we saw that this just dumped it to the screen. I can go ahead and put it into a file. So I can go ahead and I can do a greater than sign, which is a redirect. I know my screen looks a little messed up here, but so I'm living right there. So after the end of the thing, you do a greater than sign. I'm redirecting that output, and I'm going to put it into a file. So let's just call this guy cards.json. Press enter. And it shows me how much it downloaded. So that that was almost a 1 megabyte file. Actually, over a 1 megabyte file. 1 megabyte would be 1024K. All right, and notice now I have a file called cards.json. I have a file on my computer, and if I'll just say well here, I'll say more, another command, more, cards.json. I press enter, it lets me walk through that one screen at a time. This guy right here. Well, this is the one that just downloads it and shows it on the screen. This guy redirects it to a file called cards.json. And these are all command line, Linux command line tools that I encourage you to start learning, getting used to these things. These are not part of our normal, how we grew up using computers stuff today, right? We use mouse and keyboard and we click on stuff and all sorts of things like this. But hopefully you're starting to realize how powerful this is. You can do a lot of stuff pretty quickly from the command line. If I want to look at the contents of that file one screen at a time, like I said, I can just do this more command. There's already a program on the computer called more, which says, give me the source of your data. I will show it to you one screen at a time so you can click on it. But it shows it from the beginning to the end. If instead I want to show it only at the end, I can say tail cards.json, and this shows me the end of that file. So for instance, you might be looking at like log files on a computer to see what errors have occurred, and chances are the most recent errors are at the end of that file. So you can use the tail command to see the end of a file. All right. Similar, if I just want to dump the file to the screen, I can use the cat command, which is concatenate. And I can say cards.json. This isn't a great way for us to process it because when I do that, it's just going to dump it to the screen. All at once, not one screen at a time. Now, I could say, well, I want a cat cards.json, and then I want to use a vertical bar and pipe that to the command more, so it shows it to me one line at a time, or one screen at a time. That vertical bar is the pipe. So take the output and pipe it into another program. That arrow we use, the greater than sign, redirects the output to a different destination source. These are just Linux, Unix commands. All right. Now this was just a little exercise in learning this stuff. So in case for a rainy day, if this data source ever comes offline or whatever, I've gone ahead and I've just preserved it inside of this cards.json file. We're not going to use that for right now, but I have it if I ever want it. What we want to do is what the cool kids are doing is they're reading this right out from online. Because presumably, every single time I hit that online site, it's giving me the most up-to-date collection of cards. I don't know if that's actually true for this particular source, but the idea would be it is. When new cards get released, they add it to their endpoint here. So when I download the up-to-date version of that JSON file, it goes ahead and gives me that stuff. So I want to bring the contents of that file into my program. That makes some sense? All right, so we're going to look at some sample code that I put up a little bit ago. So inside of that directory, if you go onto GitHub, you'll see a new file in there called curltest.cpp. So one of the nice things you can do with C and C++ on a Linux platform, and you could do it on Windows as well, but generally speaking, if you're writing code on Windows in C++, you're probably using Microsoft Visual Studio's Visual C++, creating graphic user interface applications. Not the end of the world, but you are likely not leveraging command line tools like this. Now, that's going to probably change fairly soon. For those of you who kind of follow closely Microsoft's evolution, Windows is going to have Linux embedded within it. So you'll have a Linux command line in Windows. So all this stuff we're looking at here is going to be available on Windows. Why? Because it's better for power users. Historically, what was the equivalent on Windows if you wanted to do command line type stuff? What was Windows' version of that?
PowerShell?
PowerShell. Yep, there's a program called PowerShell. It allows you to do shell scripting, stuff like that. It attempts to be like the, we're in Linux, we're using something called the bash shell. It attempts to be like that. It's not as good. All right. And Microsoft would admit to it because they're bringing the Linux shell into Windows.
Do you think they would just like, yeah, that's not why we're actually bringing it in? Or do you think it's more of like, they say it's better, but.
I don't know. I think they wouldn't have adopted it if it wasn't better.
Yeah.
Or more widely used. Because I think there's also that argument that maybe they're trying to get more technical developers. Because typically if you're a more technical developer, you feel more at home on like a Linux platform. So if they want to get more technical developers to make the jump over to Windows, not that they don't use Windows, but they use Windows like I use Windows, where, hey, if I'm going to play a video game, I use my Windows machine. If I'm doing anything else, I use one of my other computers. Go ahead. Yeah, Yeah, if I go over here, if I go to terminal on the Mac, see if curl's already installed on here. Yep. So I can do curl like that. There's the whole screen. I can do curl like that, pipe it to more. I think the Mac uses the Z shell, which is like a competitor with Bash. And that the reason for that is not because Apple is something amazing. It's that Mac OS X, and this is version what, 11, 12, 13 of Mac OS X. What, I'm running the latest one. What are we at? Oh, now I don't even know what we're at because now we say 11.2.1. So we're at least, so maybe we assume 10.10 was the last one. Let's just say this is version 12 of OS X. It's built on top of OpenBSD Unix. So the Mac OS is actually a Unix operating system, which again is why I prefer it. You've probably seen me over the years run stuff from the command line because it's something that I feel more comfortable doing. And I tend to fumble more if I'm using graphical user stuff because it's not something that I use on a daily basis necessarily. All right, but to your point, yeah, Mac is effectively that at like 11 times the cost than just putting Linux on your laptop. That's actually a reasonable question. I think the answer is probably, but would I encourage somebody to spend their money on a Mac versus getting a laptop that's pretty compatible with Linux, which most laptops are now. That used to be a major problem. Linux didn't have very good driver support. If you wanted to do, call it power programming type stuff, I don't know. Mac is kind of like driving a Cadillac. You get the nice car. It's got the Spanish oak in there that you don't need, whatever, all that stuff. But ultimately, a terminal is a terminal. A Linux terminal is a Linux terminal. All right. So in any case, we want to, oh, go ahead.
Sorry.
No worries.
I know for me, for this code, I just copied and pasted it, and for me, my include
Yeah, we're getting there. Yeah, this is going to be broken right now. Yep. All right. So here's some code. Now, what we just did when we did an apt install is we installed the curl program, the application from curl that allows us to use it on this computer. Make sense? So kind of like we did a setup for it or whatever. But if I want to utilize curl from within a C++ program, I need to have access to the curl libraries to do this. So we need to install libcurl. Let's see if I can give you an easy way of doing it. So we're going to say sudo apt-get install. Let's do lib-curl. Yeah, I couldn't find it, so I have to give you the grep. So this is what you want to install. libcurl 4, and actually you can see it this way. If you do sudo apt-get install libcurl like that, and does that not give you the choices? Oh, looks like you can do it that way. So do sudo apt-get install libcurl 4. And that should download some stuff. And effectively what that'll do is it'll make the curl.h file available to you. Now, the reality here is, as I said earlier, that, for instance, we're going to write our own stuff for parsing JSON in here. There probably is a library out there in C, well, I say probably, there's definitely multiple libraries out there in C++, that people have written that allow you to parse JSON with your C++ program. Because we're writing data structures in here, writing algorithms in here, we're going to avoid using that. Generally speaking, I would say I try to avoid using third-party tools unless they're kind of an industry standard. Because one thing you don't want to do is you don't want to write a computer program, or it's solving a really difficult problem that it's just the right tool for the job to use the tool. And what I mean by that is, if you have a production application, some big thing you spend a bunch of time on, whatever, and you're reliant on like Bob's library or something like that, okay? And you downloaded Bob's library and you brought it into your code and you're using a bunch of these functions that Bob wrote for you. And then let's say there's some update to a couple of the things that your program talks to. And let's just say that the old version of Bob's library isn't compatible with it anymore. And then you go to download the updated version of Bob's library, and Bob's library doesn't exist anymore. Or it's still that old version. You know, he wrote it as some hobby 15 years ago, and it no longer is a thing. All right, make sense? So I try to avoid using third-party stuff like that unless it's part of like the industry standard, unless there's just a really good reason to use it. Curl is an industry standard tool. So using libcurl is fine, okay? That's something that's been around for a couple of minutes. So in any case, what we just did is we gave ourselves access to libcurl. So now if you go back into Visual Studio Code, I'm less concerned if you still have squigglies underneath here. It's somewhat unimportant, but my guess is they may be one away, okay? I'm not real clear on how Visual Studio Code plugs into what's actually available on the operating system. It actually seems like it plugs in pretty reasonably since it found it now. But in any case, you will need libcurl. I actually think you need libcurl. I don't think you actually need the curl program. That might be a lie. I haven't actually tried it. Maybe we'll test it here in a few minutes. I'll remove the program after we see it work and just see if it still works or it says, hey, I can't find curl. Whatever. I'm not sure if their library embeds the abilities of curl into it or if it just leverages the installed curl program. All right. But in any case, we should see some similarities up here. So we have, you know, we're working with strings, we have our IO stream, and then we brought in access to this curl program. All right. And we've seen what curl does. It lets us ask for the contents of a web page. All right. So this sample code we're going to end up embedding into our program. I'm going to walk through the sample code at first, just so we have our mind wrapped around it. And we're going to see a couple of standards. One of the things that we want to, I'm going to preheat it on this because now we're becoming advanced enough programmers that sometimes when we use third-party tools, we're going to have to adapt our problem solving to make sure we use them in the way they were intended to use, right? You know, the example I might use is like we have a laser cutter down the hall there. And, you know, whether I want to or not, I can say, well, I'll just remember, you know, when to turn the laser off, when to turn the laser on, but there's like a safety switch, right? So you got to go and you got to flip something on before the start button makes the laser go. And that's part of the process of using it is you got to say, I'm ready to laser, something like that. Okay. So you got to make sure your actions are compatible with the way the machine works. So in Java, we talked about these things called interfaces. So an interface is a set of requirements that when implemented, let's see, need to be written by the user. So any class that chooses to implement a interface, like Runnable was one of those interfaces we looked at last semester when we looked at threads. So a lot of times in Java, the naming convention is anything that ends with ABL-able. They tend to be interfaces. We had to then write our own version of public void run for that because the interface says, look, if you are saying you're compatible with the runnable interface, I'm now expecting you to have a function called run. Okay, so we're going to call this, so interfaces in Java are, let's say, a more evolved version of something that has been around for a while. In some older languages, and not even just old languages, we still use these in newer languages. This has a it has a scarier name now called a closure. And JavaScript uses these a lot because JavaScript is an old language that's been augmented to work with newer things. So we have something called callback functions. Sometimes we want or have to provide a function to another function that we intend for that other function to call when it is ready. A lot of times these are callback functions where I'll start a function to start doing something. I'll also hand it a function. And basically what I'm saying is when you're done, call this function. And this function does something else that maybe saves the file or does something else. Okay, so these guys are called callback functions. This is kind of like an interface-ish from the perspective that we're adding some functionality to something that we had to write, right? There might be a function that says, you need to give me something else that I will call for you when I'm done doing what I'm doing. And we're going to see this here in a few minutes. So this is quite common in C and C++ programming, as is functions that take pointers to things as parameters rather than functions that return values. So we're going to see some examples here where instead of us saying such and such variable equals whatever this function returns, instead we're just going to call the function and pass it a pointer. And after that function's done, the variable we passed it will have had its value filled in by the function rather than that value be returned. So this was more of an older way of doing it. I don't even necessarily want to argue which one's better or worse. It's just the thing. All right, so let's start walking through this code over here and see what's going on. So we have a variable here called contents. Now we're going to come back to this. This is our callback that I referenced earlier. Okay, so we're going to skip that. We're going to go down to my line 30. Go ahead.
So I installed the thing you said to do, and it's still giving me the
In here?
Yeah.
Okay, well, I mean, like I say, I don't know how Visual Studio does it, so just roll with it for right now. Some other folks that fixed it, right? You're squiggly, so make sure you save the file, something like that. The file's not saved. All right, so this guy up here is going to be our callback, and we'll see how this works here in a second. We're going to go into main. Here's our standard main. Now, this particular program, and actually, let's go ahead and show you this program running first, so you see how it works. So if I do ./a.out, where am I at? Oh, so to compile this guy, I need to do curl test, G++ curl test. But if I just run it like that, I'm going to get some errors. It says, hey, I can't find some of these things. So one of the things we need to do is we need to link a library. So I'm going to link the curl library in here. So you do -L, which says link something, and I'm going to link curl, which will then give me access to those functions that are found. The compiler, what it does is the compiler makes a pass through and says, is all the code you wrote accurate? Is it syntactically accurate? But at the same time, the compiler's output is an executable, right? And part of building that executable is linking other libraries that have already been built into this guy so that it ultimately has all the functionality it needs to do its job. Make sense? All right, so in any case, now we have our a.out. If I do ./a.out and do nothing else and press enter, you see it says something. It says use curl test.url. Now here's an interesting thing. If I type in just more and press enter, notice it gives me kind of a similar type error, you know, bad usage, whatever. If I type in just curl and press enter, it says, you know, here's how you're supposed to use this. If I type in cat and press enter, oh, it's a cat will allow me to type stuff out and then echo it. So that's a bad example. If I just type in grep and press enter, it shows me what the usage is. So it's very common in C and C++ programs for them to take in those command line arguments that we've been avoiding up to this point, right? We've seen it for a couple of years now, where you have something that takes in, you know, a number of arguments. In Java, it's string array args. In C and C++, it's a number of arguments and then the actual array of strings that are the arguments. But we don't really use it in some of these new, more modern languages, because typically we're interfacing with our languages in real modern programming by double clicking an icon and that thing just launches, right? But when we're running stuff in the command line, we figure it's probably going to be fairly common for us to pass in some command line stuff. So we wrote this program in a similar fashion, where our very first if statement said, you know, if the number of arguments you gave me is not equal to 2, you either gave me less than 2 or you gave me more than 2. If you gave me anything other than exactly 2 arguments, where in C and C++, the first argument is automatically the name of the program. So really this says if you gave me more or less than 1 additional argument is what this is saying. Then do a little output thing here that says, this is how you're supposed to use my program. And then exit. And notice here that main returns an int, and I'm returning a -1. So we might say -1 means something bad happened. Because I might call upon this program in another script somewhere, and I might say, try to run my program. If something bad happens, do something else or whatever. Okay, so that's what this if statement here says. It says, if you didn't call it right, yell at them. But the way we're supposed to call this is we are supposed to run it, passing it the URL that we want it to go read from. You can put anything you want in here, but I'm going to put in this cards JSON URL. All right, and we'll press enter and we'll see the output is it read it from the internet. All right, so now we know it works. And that's not reading our local file. This is reading from the internet, https://API, yada, yada, yada. All right, we'll go back into the code. So what does this code do? Well, the first thing it does is it creates a variable of type curl pointer. And this was made available to us by the curl.h file. Now, this guy right here, this if curl, this effectively means if the variable has something in it. It's pretty common in C and C++ because a null value, in Java we might say if something is not equal to null. Okay, that's what this effectively is saying. But null values are represented as in C++ as something called nil, which is actually an integer type. And true and false in C and C++ are also integer types. So really what I'm doing here is I'm asking if curl is equal to 0. That's what I'm really asking there. Does it have a value in it? But the way it would typically be written is like this, and I would read this as if curl has a thing in it. When I just tried to set it to a thing up here, what thing did I try to set it to? Whatever this curl easy init thing returns. the function that came with the curl library that says, hey, I want to set some stuff up to read over the internet. So this is kind of prepping us for that. So as long as that's cool, then we want to call a couple of other, this is how we're talking to the libcurl library. So now we have this thing called curl easy set options. And this is that example I told you where often we pass in a pointer. So here's me passing the pointer to curl in, because curl, this variable, is a curl pointer. So I'm passing this variable in. I'm passing it this, a lot of times when you see things in all capital letters like this, it's a macro that's built in somewhere in that curl.h library. So this guy is the curl option for the URL. And then I'm giving it the URL we passed in. So this is the first argument. Argument at bucket 0 is the name of the program. Argument at bucket 1 is the thing we typed in, the website. Okay, so what does this line do? It tells this dude that the URL I want to go to is the guy I typed in as my command line argument. Okay, again, this is like we went to Home Depot, we got to use the tool the right way. The laser cutter down there, I got to hit the switch. This guy says, hey, you want to use curl to open some stuff? You got to initialize it. You got to tell me what URL you're going to go to. You also have to tell me what your write function is, i.e. what your callback function is. What function should I call back when I get data? Make sense? So this is another thing we have to do. We have to tell curl what function it should call when it receives data. And notice the name of this thing is handle data. And if I scroll up here, notice it's called handle data. I could have called this function woot if I wanted to, as long as they advertise it as woot down below. But it has to match this particular, this is like where it's like an interface. Okay, so it says, look, you need to write a function. I don't care what you name your function. Whatever you name it, no problem. Just tell me what you called it down here. That's where it lets me tell you what you called it. But that function needs to have a very specific signature definition. These are the exact kinds of values it's going to take in. It's going to take in a pointer. It's going to take in a size. This is something called a size type. It's probably an int or a long. It's going to take in, I don't know what, in mem. I don't know what this variable is for. We can look it up if we care, but it means something. We'll see. Maybe we can see by, number of bytes, I'm guessing. Yeah, we'll get to it from down there. So it takes in this other integer, and then it takes in a pointer to the stream that was opened. Curl opens up a connection over the internet and then streams data down from that connection. And what do we do with that stream? This gets called, it calls this function. This first thing we're calculating here is the number of bytes that we're going to be dealing with in this particular call to handle data. There's no guarantee that handle data is going to get all that data at once. It's going to get the data from the stream, and it's going to keep getting data from the stream as long as we can. All right, so right here, we're going to set a variable called numBytes equal to whatever the size that was passed in. So this is probably the size of the data that we're receiving. Maybe it's char data. So maybe the size is 1 byte times, this would probably be the number of those elements that we received in this particular call. So the total amount of bytes that we need to store this information is the number of things times the size of those things. I'm sorry. Yeah, well, I said it right, but I kind of said it backwards. The size of those things times the number of the things we received. All right. So then we're going to go ahead and we set this variable called last char. And this guy is going to walk us through memory. So notice we take our pointer. So our pointer leads to somewhere. Some pointer was passed in. We're going to see how we use this pointer here in a second, because we're actually adding things to this pointer. So we're going to move to that. We're going to get the last character that we read, and that's going to be go to our pointer, go to the string that lives at our pointer, then take this number of steps forward through memory, -1. Last legal bucket is the length -1. Okay, so this will get us the very last character. And then what we're doing is we're going to set the thing that is at the end of the string equal to a \0. Look at the comment before this. Strings are terminated with \0s in old style C and C++. Curl's been around for a few minutes, so it was probably written in C. So it's using char pointers for strings, not the more advanced, more recent string type. All right, so we'll go ahead and get the position of the last char, and then we're going to set it to a \0, terminating the string. All right, now notice here, I am using a new style variable up here called contents, and it's of type string. And we can think of this as similar to Java strings, not quite as friendly, but ish. Way more friendly than char pointers. Not that we shouldn't still have fun with pointers and addresses and things like that. And we're seeing here that we're having to live in two different worlds, right? We're living in the world where, hey, we like working with strings. And by the way, it's 2021. And then we also live in the world of, hey, we're using some old libraries. And oh, by the way, it's 1982. Make sense? Okay, we're living in two, we have our foot in two different worlds here, and we're trying to marry these two things together. So once I have an actual string, so what I'm doing right here is I'm saying, so the string I'm appending is this guy, pointer. This is going to be the string that's passed in, but it's not terminated with the string termination character. So all of these lines right here, their job is to go through there and get to the position in memory that should be the string termination character in the pointer that was sent me, and add the string termination character that was sent to me. What does that let me do? It lets me now treat that guy as a more modern string data type. So that's the whole purpose of those lines right there. Make it so pointer can be treated as a modern string. End of pointer manipulation to make it work as a modern string. Make sense? So this chunk of code is just doctoring the data we received in this callback function. It's plopping a string termination at the end. Then what are we doing? We are using the modern string thing to append to it. You actually can use normal string concatenation. I'm not sure if we have to use append if we're dealing with a char pointer. I think maybe using contents plus equals or contents is equal to contents concatenated with something else might require the something else to be a true modern string data type, not something that's compatible with it. So my guess is the reason they're using the append function here is it allows you to take in a char pointer, presuming it has the string termination character, and will append it, concatenate it to the end of that string. All right, so we are tacking on our the string, and then we're appending that one last character. This is the character that we originally read last. And notice here they're saying this might not be necessary. This might not be necessary. Probably depends on the implementation of the string library, whether it needs something to terminate the string modernly, or if the append worked with the old style char pointer. And then ultimately, what are we returning here? This guy returns size t is an integer type. All right. We don't really have to worry about that in here. This is more like, hey, look, we went to Home Depot, we bought this tool, this is how it works. Okay. So in the end, what am I doing? I'm returning the number of total bytes that I processed. But my string, the thing I ultimately want is the string that I've collected, that I've read over this stream. My string is actually being collected inside of this variable called contents, whose scope is global inside this program. That make sense? Now, did they technically ever set it to the empty string? They did not. I would say this is poorly written. I would probably initialize it to the empty string. They are relying, the sample code here is relying on the fact that a default string must be the empty string. That must be the default value. I would say good programming practices never rely on default values. If you want an integer to start with a 0, you put a 0 in there, even though it probably starts with a 0. Make sense? All right. So again, this guy builds up our string internally, and what it returns is the number of bytes that it processed. And all that happened as a result of us telling the curl that the function I want you to call when you receive crap is this thing that I wrote called handle data. You can name it whatever you want. It just has to match that signature. So somewhere in the documentation, it's going to say for curl opt write function, that write function is an interface. And it says, you need to give me a function that exactly takes these kinds of parameters, because that's the guy I'm going to try to call. I'm going to call whatever you handed me here, and I'm going to pass it exactly this kind of stuff. So you better be ready for it. Make sense? All right. Finally, all this was just set up. We said, look, here's the URL I want you to read from. Here's the callback function I want you to call when you start getting data. Now we're prepped. We're ready to go. What's the next line? We say, go ahead and perform the call. And what we're going to get here is a result. Okay, this is a curl code result. So at this point, we have our data. Whenever we get to this next line, this guy blocks. Okay, so this guy does what's called blocking. Remember we talked about threads last semester where we can do something that does not block? Well, this guy's going to sit here on this line until it's finished reading in the contents of that URL. And as soon as we get the contents of that URL, then we'll go ahead and effectively close the connection. That's what this curl easy cleanup thing does. You give it the pointer to your curl object, yeah, I guess we can think of it as a curl object. You give it the pointer to that guy, and he takes care of whatever needs to be taken care of to clean up the connection stuff. So then we'll say, if everything worked out, that is, if res has something in it, then we'll go ahead and just write to the screen our contents. Make sense? Contents is that global string that we collected our data into. All right. Now I just put a little sample code after this showing that we can build up. So I gave you an example of some string concatenation stuff. So in here, I just created a little temp string, set it equal to the empty string. And I just went through the first 5 characters in contents and concatenated it onto temp. So you should see this looks fairly similar to Java, right? And then in the end, I just outputted temp. So this should get me the first 5 characters from it inside of a variable named temp. So I write out the wall, and then at the very last line, I just say, here's the first 5 characters, proving that I was able to build some stuff off of that. Okay. Otherwise, if res is not a thing, what do? We spit out some sort of error. This would be the return type. So res is the result of getting the error code from it. So when we do our cleanup, it's going to say, this says, did it all go well? If the error code is 0, everything went well. That's the typical POSIX standard in Unix. A program always, typically programs return an integer. 0 if things went well, something other than 0 for umpteen number of error codes that could happen. Kind of like exception handling in Java, but much more old school. You can have error 1 or error 2 or error -7. If you want to go into the negatives just to be weird, I guess you could. So somewhere there's going to be documentation that lists, here's all the things that could go wrong. If you get a return of 1, that means this went wrong. If you get a return of 2, that means this went wrong, so on and so forth. Go ahead.
Is that really where you get the error kind of thing?
It's similar. Yeah. So somewhere in the HTTP documentation, it says what a 404 means. I don't think that there are 500 plus errors in HTTP. So I'm guessing those numbers must have another meaning. But yeah, I mean, you're exactly right. It's that type of thing. A 404 means something. And again, it's because HTTP has been around for a few minutes. All right. And this kind of goes back to some of the things you've heard me say in probably 3 classes, and even if you've had other classes with me, is that, it's beneficial to see things through this historical lens, because as you're seeing right now, sometimes we still need to do it. Okay. But more importantly, it also makes us appreciate what these more modern languages are doing for us, covering up. Okay. And as computer scientists, we need those skills. If you're somebody who goes to, and this is really the differentiating factor between getting a degree in computer science versus going to one of those coding boot camps. There's nothing wrong with going to a coding boot camp, but you're going to come out with a skill on how to do a specific task, not the underlying thing that will allow you to wield, the next language that comes out and look at documentation and kind of have a chance of knowing what to do and all that stuff. Okay. So any questions on the logic that happened here? Followed it pretty well. We stepped through it. I know it feels a little bit complicated, but now that we walk through it line by line, all make reasonable sense. Okay, and then if I go out, well, you saw me run it a second ago, so notice this was my temp, first 5 characters that I read in, and this was the rest. So this is the closing square bracket of my opening square bracket. All right, so what I want to do now is I want to go ahead and bring these things into an object. All right, so for our homework, using our curl test.cpp as an example, create a URL class that has the following: a constructor that takes a string as a parameter representing the URL that you want to read from. A method called get contents, which returns the contents of that URL as a string. The goal is I should be able to do something like URL U1 is equal to new URL HTTP www.google.com. URL U2 is equal to new URL http://www.yahoo.com, whatever. And then I should be able to do like a cout U1 dot get contents. And I should be able to do, let's fix some stuff here. Oh, it won't even give me the opportunity to, there we go. I'm going to steal this line. So we want to create, basically what we did today, we want to suck it into an object-oriented manner so that in the future, whenever we want to open a URL to something, we can just create an instance of our URL object, pass it the string that we want to connect to, and behind the scenes, it does the magic. What magic? The crap we walked through today. That make sense? So I'll put in here starting point. Let me go to my GitHub. Um, 300 Hearthstone game. And then let me make sure I do a final push here. That's annoying that it's not remembering. I need to set those, yeah, usually, at least historically, once you do it the first time per repository, it remembers it. I bet you GitHub does use some environment variables. I bet you I can set a couple of Git environment variables where it'll remember some things. I don't know if it'll let me do that for a password, but whatever. All right, awesome that. So now you have the most local or the most recent version of this guy in here, just to make sure that we're safe. And here's a reminder. Remember, when you compile this guy, you need to link the curl library. We even add a note. And let me go back the other direction. Note, don't forget to link the curl library. Yep. Make sense? Note, don't forget to install curl and libcurl4. All right, let's just make sure that I didn't introduce a new bug to this or anything. Nope. So you should have a working version of the code. All right, so does it make sense what I'm asking you to do? It's just like we kind of looked at last class where I said, hey, here's this card, and we want to create an object out of this card. That was a real life thing. Now we're saying, hey, here's this tool that's a little cryptic, and we want to make it a little bit easier for us to use. We know we're going to need those wires, right? We're looking at the difference between a procedural version of a telephone and an object-oriented version of the telephone. We just walked through a pile of wires today. Now we're going to pull those wires inside of an object. Wires are still there, but ultimately it's going to let me just say, hey, I want to get some stuff from a URL. No problem. I'll just create one of my URLs. I'll create another one of my URLs. and then I'll just get the contents of that guy. Poof, worked. Completely knowing that those wires are in there. Questions, comments, concerns, bribes. All right, I'll see everybody on, what day is today? Tuesday? See everybody on Thursday. Yes, you could use curl to copy the entirety of a Wikipedia page. Anything that's on the internet. See, this is why, Emily, you should have taken me up on running you were supposed to run the Zoom thing, everything.
I can't, I have free Zoom. You don't get space for free Zoom.
Really?
Yeah,
So even if you're on your cu.edu?
yeah, we only have like, if we have more than 2 people, we only have 45 minutes.
Really?
Yeah, it's really annoying.
Yeah, that's why we're trying to look for action last month. We're trying to get those back.
See, I assumed that all cu.edu email addresses fell underneath the library
They
or
have them
the
separated somehow.
okay.
Probably to reduce.
Well, I could always just give you my account,
I mean,
and then you can run it.
It's probably to reduce the amount of cost.
Well, yeah, but I'm sure that we already pay some hefty thing for just an enterprise site license.
Yeah.
But maybe there's a number.
Probably-
You're probably right. There's probably a limit to the number of seats.
Yeah, and they probably only do it for the rooms in the